This is One Universe at a Time. I'm Brian Koberlein. If you've ever been around a baby, you know how fun it is to hide an object and bring it back out. The baby believes the object is gone, and in fact forgets it even existed. Fortunately, we all grow out of this and develop something called object permanence. Today we're going to talk about this with Dr. Grant Gutheil, Associate Professor of Psychology at Nazareth College in Rochester, New York. I have seen videos online, and I know that they're psychological studies. They must have been screen capped or something, but they're posted under "Children Are Stupid."
Yeah,
and they do these videos, and they show that little kids just don't think the way I do. And one of them is what we call object permanence, the idea that when it disappears, they think it doesn't exist.
Right.
How does that work in the sense of, you think that would be pretty innate that things exist?
Well, there is a fair amount of evidence that to some degree babies do think differently than we do. But the extent to which infants and young children are more like us or less like us is one of the fundamental issues in developmental science. So just to get if you'll excuse the phrase, a better definition of object permanence out there.
Okay.
It is the belief or lack of belief that an object continues to exist when it is out of your immediate sensory field. So if you can't feel it, hear it, touch it, taste it, etc., it evaporates.
Okay.
And more than that, if you really want to push the more extreme versions of this limitation, not only does it cease to exist, you forget it ever did.
I'm assuming this is in children that aren't old enough to talk?
Depending upon how you want to define real object permanence, it's in babies before 8 months or it's in babies before 24 months. But it's certainly, even in the most extreme or conservative versions of babies do not have object permanence, it shows up at 18 to 24 months.
So how do you tell that then? I mean, how do you know what's working in a baby's head when they don't talk?
I love infant research and thought for a while that I might do it. And, then you go into an infant lab and you realize, oh, these people are insane. Your subjects are, 3-month-old infants who basically are loaves of bread that poo and scream a lot.
Right.
So to be a good infancy researcher is to have both an incredibly creative notion of what good experimental design is, and to also be incredibly patient and kind to your participants. And it's mammothly difficult to do.
So there's a lot of noise in these experiments, not just literally, but in terms of the data, there's a lot of noise.
The way that it's done most often is what are broadly referred to as habituation and recovery studies.
Okay.
And what these rely on, the fundamental experimental measurable behavioral result, is babies look longer at stuff that surprises them, that interests them, that they don't understand.
Right. The odd thing is what we stare at.
Yeah, and just as a piece of that, how different are babies from me, that's exactly how we do it.
Right.
I mean, we do, what is it? I mean, we have exactly kind of that dog tilting their head to the side thing.
Something odd appears in our field of view and we stare at it.
Yeah, exactly.
We rubberneck.
Yeah, exactly. And the babies do the same thing. So you take advantage of that behavioral measure. And what you do is construct very elaborate and very specifically controlled experiments in which you show them different stuff and you see what they look longer at. And the experimental data are, in condition A, they looked longer, they looked for this amount of time. Condition B, they looked for this amount of time. Is there a significant difference between those two conditions or not?
Right.
If they look longer at something, the implication is that they understand, or at least understand enough, that they're trying to figure out what's going on. So the thing that they look longer at is something usually called of an impossible event or a magical event.
Right. Something unexpected, and they tend to look at it longer.
Yeah.
So you cover two things and it moved to a different place without actually
moving.
Seeing it move.
Yeah. And how did they respond to that?
Right. Okay.
And the way the object permanence stuff goes is you show them a situation where something violates basic physics.
Okay.
It reappears and disappears.
You do a magic trick, basically.
Yeah, you do a magic trick. And are they surprised by that magic trick or not? If they are surprised by the magic trick, the inference is they are surprised because they have object permanence and they're looking at it the same way an adult would and saying, wait a minute, that can't happen. How did that happen? I don't understand that. So they stare at it longer.
Well, that's interesting.
If they don't have object permanence, it's like, okay, fine, whatever. Oh, look, butterflies. I mean, they don't have the conceptual problem, so they don't stare longer.
Right. So when you reach a certain level, magic magic tricks become interesting.
Yes,
because
if you
they're
have the
unexpected.
conceptual ability to understand that, wow, so a Buick can't float 18 feet in the air on fire and then disappear. That's not the way the world works.
And it's like misdirection, too. The
Yes.
same thing, that we expect something to happen in a certain way,
Exactly.
and a magician would take advantage of that.
Exactly.
Okay.
That's really the data, more or less. You develop any number of tweaks on this procedure, refine it and refine it and refine it to the point that you show them a set of events, and the only interesting thing that differs between condition 1 and condition 2 is a test of the conceptual problem that you're interested in.
Is the object still there when you can't see it?
If you believe that, you must respond in this way. If you don't believe that, you must respond in this other way.
Right.
That's the data. That's how they do it.
Okay.
And just to say what a problem is with a lot of these studies, a lot of people, a lot of psychologists say you're still trying to crawl inside a 3-month-old's head
Right.
and figure out what's going on, and that's really difficult, and these are broad and difficult inferences to make. And the infant cognition guys say, yeah, you're right. That's why we've done 18 million variations on this, and we
Right.
have controlled for every conceivable thing you can come up with.
Right.
It becomes at that point in the responsibility of the skeptic to say, okay, I don't believe that a 4-month-old has object permanence. Okay, fine, explain the result.
Right.
And they can't.
My understanding would be then that it's not that psychologists are saying the baby's thinking, oh, there's a thing, oh, it went away. It disappeared. It doesn't come to mind anymore.
Exactly.
And they don't think of it still being there because they're not holding it as an idea.
That gets into the memory aspect of this as well. You can't have mental representation, you can't have object permanence if you cannot form memories.
Right.
And there's an old school thing going back like 50, 75 years that babies don't have memories. Babies can't form memories.
Right.
Okay, that's goofy. It's related to something called infantile amnesia, where none of us remember much of what happened in the first couple of years of our lives.
Right.
Most people's solid, verifiable memories stop at about age 2.
If you have a small child and you ask them about things, they remember it, and then as they get older, they forget it.
Yeah, they don't.
So if they're 4, they might remember something at 2.
Yes.
But then when they're 8, they don't remember that event at 2 anymore.
And that's been taken as evidence that babies don't form memories. Babies don't form memories, therefore
Right.
babies don't have object permanence or mental representation. And that's goofy because they do form memories. There is a great deal of very good research showing in some cases that babies can form memories, very limited memories, but can form memories in the womb in the last couple of months of pregnancy.
Right.
So the idea that they don't have memories is goofy. So
Right.
they do.
Well,
so
wasn't there a language study that, like, if they hear certain tones,
yeah,
they're familiar with that? Or?
there's a lot of different ones. The most famous one's called the Cat in the Hat study. I mean, developmental psychologists have all these kind of goofy names.
Goofy names for it. Yeah, well, we do too. We call things quarks and stuff.
Yeah, so it kind of works the same way, I guess. But you have a pregnant woman sit in a chair and read the Cat in the Hat for twice a day. Just read the whole book, put the book on her belly, and just read.
And read the book.
And the kid can hear. The day the kid's born, you do various conditions, but essentially, does the kid recognize the story?
Right.
And so you have the mom read Cat in the Hat versus a different book, probably a different Dr. Seuss book.
Right.
Or you have a different woman read the Cat in the Hat and the mom reads something else. You see differentially how the kids react. And it's pretty clear that the kids remember mom's voice reading that book.
Right.
Now, I want to be clear about this because I get students who say, wait a minute, that means they understand the Cat in the Hat? No,
No, they don't understand the Cat in the Hat.
at all.
What they hear
recognize,
is... Wah, wah, wah,
yeah,
wah,
they
wah,
hear
wah,
the
wah, wah.
sounds. They recognize
Okay.
the sounds. That's the memory.
Yeah.
So they have memories very early on. There's other research showing that you can get really solid memories with babies with training and reinforcement really early on as well.
Right.
So
train them like cats, and, and they remember
and
things.
they remember. There's still more to mental representation than that. There's a conceptual understanding of how does my world work? How does the universe work? And this is part of a much bigger and messier controversy in the field, which gets back to your original question. How alike am I to a 4-month-old versus how different am I from a 4-month-old?
Well, I would say probably it's we're not even that much alike to what we think we actually are.
That's certainly one way of looking at it.
We model our world in terms of words and that we're logical and rational.
Yeah,
and
we're
I know
not.
We've done things like blindness studies where you can switch someone out completely, and we think they're the same person because they should be the same person. And we just don't think about that.
And that's actually cognitively really useful impossible, because that only happens if you're dealing with an individual that the only thing you care about is their overall behavior.
Right.
You don't need to recognize an individual, so you don't.
We're mentally lazy.
Yeah, and
so
the
we
thing
make a
is,
lot of
mentally lazy
approximations.
works. It
Right.
does, because why clutter your brain and your thought process up with a whole bunch of crappy detail that is irrelevant?
Right.
You don't need to remember what the cashier at Wegmans looks like.
But we think we do.
Yeah, we're wrong. I mean, and, people get really bent out of shape about that, in that, well, you treat me like an object, or my customers don't pay me
psychology,
attention.
right.
Yeah,
And
and they're right. We do. That's how we're wired. Get over it. I know it makes you sad. I don't care. It's just what is.
This is why you're evil.
Yeah,
You
this is
treat
why-
us like machines, and we don't like that. I am not a number. I am a human being.
Yeah, we're all special snowflakes, except we're not in
Right.
the vast majority of cases. But there's this broad theoretical split in the field. On one side is a whole bunch of people who are more likely to believe that babies are more different from older kids and adults.
Okay, there's some dramatic shift.
Yeah, several
between-
dramatic shifts.
Okay, several dramatic shifts.
And there's another group that says, no, the real story, the fundamental story is that we are fundamentally and qualitatively the same.
Right.
And what development consists of is not radical conceptual or other kinds of shifts. You just get bigger, better, stronger, and faster at doing the same stuff.
Okay.
So what differentiates a 6-month-old from a 6-year-old is just that the 6-year-old has more experience, has a more fully developed brain, and is able to do exactly the same things, just a hell of a lot better.
Are we then fundamentally different from, say, other primates, for example?
Oh, that's a fun question.
Because it seems like an easy model to do would be that, they start off as puddle, and then they may have like dog-like intelligence, and then chimpanzee-like intelligence, and eventually they're as smart as humans. We think of this as intelligence as kind of following a scale. And I know there were some studies with, I think it may have been bonobos, where they teach them some basic math, and they can do it as long as there isn't the little raisins there that they immediately grab towards, which little kids do. Little kids will grab towards something even when they know they're not supposed to. They'll grab it and go, I'm sorry.
I can't help it.
Because they can't help it. And yet, as they get older, they lose that.
Right.
The way our brains are wired, are we cognitively different?
That is the core question. It's a nativist viewpoint on one side, which says we're a lot more alike to our primate cousins, and there's much more of an associationist viewpoint that says, no, we're actually very different. And there's evidence on both sides. I mean, if you look at the ape language stuff, bonobos are scary.
Right.
Okay.
In many ways, very similar to us.
And I want to preface this just by saying I understand for anybody who knows the ape language research that it is controversial, that there's a lot of stuff out there about the primates being treated badly, and there's all kinds of controversy. But aside of that, if you look in a bonobo's eyes, there's somebody home at a fundamental, just human level. I look at my cat and I see a 4-footed furry thing that purrs. You look in a bonobo's eyes, you see a person.
Right.
It's either fascinating and wonderful, or it's a kill it with fire moment, depending upon the individual who's looking. But there's somebody home in there.
Right.
That argues that they're much more like us than they are different.
Right. Because we see that in babies, even without permanence. There's something.
There's somebody
there.
home.
Somebody's
man.
home.
Somebody's home. But there's been a whole lot of work on teaching bonobos language.
Right.
And I'm not going to go through all the crap on sign language. It doesn't work. Seriously. Have you seen an orangutan's fingers?
Yeah.
They can't do sign language. Teaching them to speak. They don't have the voice box. That's crazy.
Right.
But you can teach language, syntactically structured communication to a bonobo. They will learn it. But the thing is, and here's where it's a problem, they can learn it, which means they're much more like us than different.
Right.
Yeah, they can learn it, but even the most famous case, which is a bonobo named Kanzi, who did some dramatically cool stuff, especially with receptive language, not production, but the ability to understand spoken English language.
Right.
Really phenomenal stuff. The difference between even Kanzi and a human infant and toddler is Kanzi has to get up every day, or had to get up every day, and go to language school.
Right.
There's not a 2-year-old on the planet ever went to language school to learn their native language. It doesn't happen. They can't help it. It's how we're wired.
Right. So there are fundamental things that are native to us, and yet there are still lots of similarities. And where that comes out is hard to distinguish.
And that's why the theoretical fight exists. And the object permanence stuff is another example of that.
Right. You're listening to One Universe at a Time, I'm your host, Brian Koberlein. We've been talking with Dr. Grant Gutheil, Associate Professor of Psychology at Nazareth College, about object permanence. In the second half of our show, he'll ask the questions and I'll answer. Today, Dr. Gutheil is curious about why Pluto is no longer considered a planet.
What happened to Pluto? I mean,
nothing happened to Pluto. It's still there.
It's still there, but why isn't Pluto a planet? I mean, when I went to school, you'd make the little styrofoam models of the solar system, and there are 9 planets. Please tell me there were 9, and I remember that correctly.
There were 9 planets.
There were 9, right?
Yes.
Pluto's one of the 9.
Yes.
Who wakes up one morning and decides, you know what? You're not a planet.
I'll answer your question with another question. Why is Ceres not a planet?
I have no idea.
You have no idea.
You want to know why I know Pluto's a planet? Because I made a little model out of styrofoam when I was in school.
You were told that it was a planet. And Ceres is the largest asteroid in the asteroid belt.
Okay.
It's smaller than our moon. How big is Pluto?
I have no idea. It's not large.
About the size of our moon.
The idea is if the asteroid is an asteroid and not a planet, then Pluto is maybe not an asteroid, but certainly not a planet.
It's an interesting thing because when Ceres was discovered, it was called a planet. And it very clearly orbited the sun. It very clearly had size and dimension. You know, we could see basically what it was. And we called it a planet.
I guess the thing that bothers me about this is there are fundamental things that astrophysicists should know. What a planet is, and what it's not. This shouldn't seem to be something you make a mistake about.
That's somewhat an arbitrary definition.
Okay.
What do we mean by a planet?
All right.
And this is, Ceres is a good example because when it was first discovered, we called it a planet. It orbits the sun. Planets orbit the sun.
Got it.
And then we would find other ones. We found Vesta and Pallas and all of these other ones. They're smaller, but they're still orbiting the sun. Do we call them all planets? And what happened is in the early 1800s, after we discovered Ceres, we discovered other ones that were all kind of in the same range. They were all in the same distance between Mars and Jupiter.
Okay.
They were all small.
Okay, so that's where these asteroids hang out between Mars and Jupiter.
Right, between Mars and Jupiter is what we call the asteroid belt.
Got it.
And so you find multiple planets, quote unquote, between Mars and Jupiter that were small. They're all very similar. And as you find more and more of them, you find out actually there's nothing unique about Ceres compared to other bodies that are in that region. Okay. There's lots of them in the same region. They're all in a general same type of size. So that's what we changed Ceres from a planet to an asteroid.
And you're saying that Pluto is basically a planet by historical accident.
Right. When we found Pluto as the only object there. Well, now we know there are lots more.
Okay.
And they are in the same general range. They're small like Pluto, and they're very different from the planets that we see normally. And so as we found more and more of these objects, these Pluto-like planets, if you want to call them that, it was decided that actually classifying Pluto not as a planet makes more sense.
Is the word planetoid... Is that something I guess pulled out of sci-fi literature?
No, planetoid is anything that would orbit the sun, whether it's an asteroid or except for a planet perhaps, but a planetoid would be technically any body that orbits the sun, regardless of its size. You know, the asteroid belt, we now have thousands and thousands of bodies, most of which are very small, but some of them, like Ceres, are moon-sized. And so that's why we sent a probe to Ceres and Vesta. They're roughly moon-sized. They're fairly circular, spherical in shape. You look at Pluto. Pluto is similar. It has its own little moon.
Right.
And
so there's a moon around Pluto?
There are more than one moon. There's one big moon.
Is it bigger than Pluto?
No. It's actually big enough, though, that the center of mass is outside of the surface of Pluto. So sometimes they would call Pluto a double planet.
Okay, my brain hurts. Okay, so what makes it a double planet is it's difficult to distinguish between the planet and the planet's satellite?
No, it makes it a double planet in that if you look at the Earth and the Moon, we have a really large moon.
Yeah.
But if you put the Earth and the Moon kind of balancing on a seesaw, what would be called its barycenter, its balance point, if they were just sitting there.
Okay.
The barycenter of the Earth-Moon system is inside the Earth.
Okay.
So it's not outside the Earth. When you do Pluto in its largest moon, it is outside.
That theoretical balance point is somewhere between the two objects.
Right. And so some people would argue that, in fact, if the barycenter is outside of the planet, then it's a double planet, not a planet and moon.
Okay.
And Pluto is the one example of that.
Okay.
But there are also multiple smaller moons that we know, and we'll probably find more when we do the flyby mission.
Flyby mission.
Well, there's a New Horizons probe that's heading towards Pluto. It'll be there.
We're actually still sending things out? I thought NASA basically had they had a garage sale and pretty much nobody works there anymore.
And so it's getting there.
Okay.
So this past week, we've actually just reached Ceres, so now we're going up towards Pluto with a different mission.
Okay.
So
That's
we're starting to see these bodies, but as we found more of them, we're seeing that they tend to group into families. They're not individual. I mean, the planets by themselves, Jupiter and Saturn and Uranus and Neptune are these large objects. They dominate their orbit, and there isn't a lot that crosses its path that's of comparable size.
Right.
Whereas things like Ceres in the asteroid belt or Pluto don't. There are other bodies out there that are of similar sizes, of similar orbits, in a range. And so you look at Pluto, you see similar bodies with it.
The Plutoids. Oh, man, that's beautiful.
But there's nothing special that says this is a planet. Whereas if you look at where Neptune is, there isn't anything near Neptune. Of Neptune's size.
So this is clearly more of a psychological than an astrophysical question, but
emotionally.
Why do you think this has pissed people off so much?
Because
people got mad.
Oh, people are still mad.
Yeah.
Neil Tyson still gets angry letters from 6-year-olds, This is something that people are emotionally connected to. When you name something, you possess it, you own it. It's the dog that you name that lives with you
is your dog.
Is your dog.
Right.
The other dog, you might care for it in an abstract sense. But
whatever.
In the general sense of, that might be someone else's dog, but this is our Pluto. Let someone else worry about
our Pluto.
Yeah, I mean, people are connected to it that way.
Wow, that's bizarre.
And in some sense, it's not that we didn't know how to classify it, but as we learned more, we got better classifying at it.
Okay, you see, that's a problem in a different way, I think, that when I woke up one morning and found out that, Neil deGrasse Tyson rolled out of bed and decided, by fiat, Pluto is no longer a planet, that didn't really bother me. But the thing that I thought when that event happened was more that, oh man, he's going to get hate mail because that makes science, that makes astrophysics look completely arbitrary.
Yeah.
You can't be wrong about that basic stuff.
Right.
It's either a planet or it's not. We should have figured that one out a while ago, and that should be stable.
Right. What we know about Pluto hasn't changed, but what we categorize it has changed.
That's a subtle distinction for people, man.
Well, but it's no different than saying, okay, if we said, you're an adult at 18.
Versus 21.
Right. We could say, it's 21. So 21, now you're an adult, period. It hasn't changed what an 18-year-old is. It doesn't change.
Do we make adulthood start at 40? Speaking as a developmentalist, yeah.
Well, I don't know. Maybe we never have adults, period.
Exactly.
But it's just an arbitrary designation. We have to draw a line somewhere.
But we can get away. When I say we, I mean psychologists and social scientists. People give us more space than they do you guys, and the reason they do is terrible. It's because they don't trust what we say anyway.
Right.
They expect you guys to, in capital gold-plated letters, to be right because you do science.
Right.
And this sort of event, I am sure, gives some credence to people's, it's all just a theory. They don't even know what Pluto is. They can't even tell if Pluto's a planet. I mean, good God, these people are stupid.
That's, the thing about science is that it is subject to new information, and we adapt our models based upon that new information. And this is a classic example of that. When we first discovered Pluto, it was the only thing out there.
It's the only thing we could see.
The only thing we could see.
Right.
And it was very clearly not asteroid sized. I mean, when we first discovered it, we actually didn't know how big it was because all we could say is how bright it was. And its size, you could have something that's large and dim that would reflect as much light as something that's small and bright. And so you just have to make some estimation in terms of how big it is.
That's probably a really different question, but I'm fascinated by the notion of, I can get the idea of a bright or dim star.
Right.
But planets don't produce their own light, so it has to be reflected light.
Yes.
So bright and dim. I don't know if you want to go there, but that's very interesting.
Okay, here's a good example. If you look at pool balls.
Okay.
So you're playing pool. If you looked at the 8-ball, and you kind of imagine the 8-ball, most of it's dark.
Right.
But at some point you'll see this bright, glossy reflection.
Right.
So if you took a picture of that in dim light, what you would see is a small, bright point, even though the whole thing is
And the
larger,
small bright point is clearly the white circle
is
with
that
the 8
right
in it.
little
Yeah.
reflection.
Yeah.
If you looked at the cue ball, you'd see the whole thing as white because you would see it. It would look very large.
So Pluto could either be literally a dark planet,
Right.
just in terms of its substance.
Right.
It either is lighter or darker, and so it would reflect either more or less light.
Right. And a lot of
Okay.
it depends upon what it's made of, which we
Right.
can't get from just looking at a photographic image in a simple level.
Right.
One of the problems we have is people think like the moon is actually very bright. It's actually not. The moon is the color of asphalt.
Really?
It's actually really dark.
Wow.
But again,
See, that's just wrong. The moon is the color more or less of burned charcoal ash. That gray.
Yeah, it's grayish more
Yeah.
than dark gray. But
Yeah.
there's it's not very bright for what we would think on the Earth as being very
Man,
bright.
I would think of it as very light gray.
Well, but the thing is with perception, if you're against a completely black background and the space
and you're
that
not
we have is
completely black,
dark,
it looks
bright.
Yeah.
And so, when we take an image of something, we brighten it up so it looks like something that's actually really bright, and it's not. And the same is true with a lot of asteroids and
Dresses.
and dresses.
Sorry.
Yeah, we'll
I
go
shouldn't have
down
gone. I shouldn't have gone there, but I couldn't help it.
But yeah, I mean, so the question when you first see Pluto, is it more like the moon, at which point it's fairly dark and it would be fairly large?
Okay.
Or is it something that is ice covered? So Europa, for example, one of Jupiter's moons, is extremely bright. It's extremely reflective.
Right.
If it was covered in ice, then it would be very bright because
Right.
snow, for example, is very bright.
Okay.
And so if you're trying to figure out some mix of charcoal to snow,
Okay.
and you
the
don't
charcoal
know-
to snow scale.
yeah, the charcoal to snow scale. Yeah, it's actually you can do a reflectivity. You can do how much what's called its albedo,
Okay.
which is basically the charcoal to snow scale.
Wow,
How
there is a
much light-
charcoal to snow scale.
Well, yeah, I mean we call it albedo.
Yeah.
It's basically what fraction of light that hits its surface will be reflected back.
Not for nothing, you do a lot better calling it the charcoal to snow scale. Somebody should do something
the
about
charcoal
that.
to snow scale. Yeah. So we have that idea of brightness. As we've gotten better images, we've now got a pretty good idea of what its size is. And yeah, it's moon sized. It's not planet sized. And so, you could say, yeah, but it has a moon, but so do asteroids. There are asteroids that have moons. So that doesn't make it a planet.
All right. So I get the science. It makes sense. You've got the data to back it up, but I think this still gets to that really fundamental problem that a lot of people have with science.
Right.
That scientists love. We love that stuff changes. We love that we get it better. We love that we
Right.
learn more. But most people are saying, wait a minute. If it changes all the time, and if you guys can't be sure that a planet's planet, how can we trust you to do anything?
I'm willing to make a bet.
Okay.
After we do the flyby of Pluto and after we do the flyby of Ceres, there's going to be this whole flurry of information.
Right.
I'm willing to bet that Ceres and Pluto will be reclassified as planets because of it.
Because people just want that
They
to be
want it
so.
that badly.
And, getting a new planet's kind of cool.
Yeah, then
now
there'll be 10.
we had 9, now we have 10, so now we're cooler.
Yeah.
Okay, yeah, I can see that. The psychology there makes a whole lot of sense.
Let me just see if it can go to 11.
Well, yeah.
We've been talking with Dr. Grant Gutheil, an associate professor of psychology at Nazareth College. Our program is produced at the Rochester Institute of Technology with support from the RIT College of Science. I'm your host, Brian Koberlein. Thanks for listening to One Universe at a Time.